This session now is about share your model, public models in Transcribus. We always had some models available, but more for demonstration purposes. We were a bit cautious to come up with larger models because, of course, you read German current and then you expect that it can read really all kinds of German current or English writing or whatsoever. And for historical documents, I think we are still rather far away from having general models which are really powerful and which behave like models for maybe modern documents or like for OCR, for printed documents. However, I think it is important also for the community to see and to give you the possibility to share your model. And so you will nowadays find, I think, something like 25 models already in Transcribus, mostly based on large amounts of documents. And I'm very grateful that some colleagues are now willing to show you how they produced these larger models and what the background is. That's also, of course, very important to see in which context such models are created. The first one who will introduce us his model is Achim Rabus from the University of Freiburg, and he's working with Slavic documents.
All right, I'm a Slavist and I'm interested in Church Slavonic. Maybe not very many in the audience are interested in Church Slavonic, but I would like to propose a specific workflow for producing these models. I have two generic models. The first one is for Russian so-called Polu stuff, which is for 16th, 15th century writing. The CRR of the model is 3.8%. I used 170,000 tokens for training. And the second one is a really generic model with more or less a similar CER, but considerably more tokens in training data, almost 400,000 tokens in training data. And this model is capable of transcribing manuscripts written in so-called Ustav, which is the oldest writing system down below, as well as manuscripts written in Polu Ustav, as you can see here. So this model is capable of transcribing old manuscript from the 12th century and also models manuscripts from the 15th, 16th century. This is kind of a generic model. Of course, as I told you before, those who attended the large model workshop, these models introduce some hypercorrect forms. Because, of course, there was linguistic change between the 12th and the 16th century, and the model learned certain linguistic features from one period of time and tried to apply it to another period of time. This is a drawback of generic models, but I think it's better to have one than to have none. And I would like to propose this so-called recycling approach, which means I didn't produce ground truth manually at all. I just browsed the internet and copied freely available electronic editions. As well, I asked a couple of colleagues who produced editions in printed form to send me their Word files, and I used these Word files to train the model. I copy-pasted it after some pre-processing into Transcribus and ran the model training. And I think this is quite a reasonable approach because there are so many Word files around. Yeah. And you all know from your community who is a more, say, conservative colleague who produces editions in the traditional way. But if we could reuse and recycle these sources, we would all be better off. And this is my recommendation for you all. Thank you very much.
Ja, editions to use it as ground truth. For example, artists tend to fill in abbreviations or modernize language. Did you have this problem?
Yes, we did. But in my field, people tend to produce very faithful, linguistically faithful editions. So there's no normalization and no emendation. But of course, we introduce noise due to heterogeneous editorial principles. But in my experience, more data is better than no noise.
What was your experience with the diacritic recognition?
Diacritics is difficult. And in parts of my training data, the editors resolved to omit all diacritics altogether, which is the model learned to ignore akut and things like that, which is not very good. But in the first model, this is the case. The second one has some diacritics. And this is, well, everything what is between the lines, in my experience, is difficult for transcribers.
I actually have a comment. I think this is a very helpful method, but sometimes you don't have the print text available, but it would still be much easier to train on a ground truth, to create a ground truth from the print edition, but then what you would have to do is export them as pages and then use them as TI for manuscripts, as T2I for manuscript, right? So in that case, maybe the...
You're talking about scanning printed editions to produce ground truth, right? Yes?
Yes, more, not just the ground truth, to prepare the text from in transcribus for the printed edition, which will be much easier. And then you can use the output of that for manuscript editions, from manuscript copies of the same text.
Sure. Yeah, that's a sensible workflow, definitely. Yeah.
Except that this means a feature request to extract the text in per page segments. But
transcribers can do that, isn't it? So transcribers has a feature to export the transcription to Word or XML or whatever. That's no problem.
Right, okay, yeah.
The next one is Stefan Satthammer, here from the University of Innsbruck. And he will talk about Neo-Latin documents.
Yeah, I now tell you something about our model we trained inside the project Nos Chemus, Nova Scientia, Early Modern Scientific Literature and Latin. Let me say a few words about the background of this model. The project Nos Chemus tries to decisively advance our understanding of the interrelation of Latin and scientific literature in the early modern times. The main output of the project are a couple of monographs, a database with about 1,500 representative texts in terms of chronological spread, literary forms and scientific disciplines, and a so-called digital source book. In this digital source book, we want to make all those 1,500 works which are in our database machine readable, and we want also to implement the keyword spotting. A quick overview of the ITER our model went until now. As a first step, I tried to create one special or individual model for each century our project deals with. This means I created one model for the 15th century, for the 16th, for the 17th and the 18th century. Each of these special models consists about at least 300 pages, and those 300 pages are taken from at least 4 or 5 different works or books. The works selected for the training data were selected with the aim of ensuring they are representative in terms of chronological spread and used typefaces. As a second step, when I had a couple of individual models available, I merged those individual models to one general model called Nos Cemus General Model version 1. As an example, here I have the special model for the 17th century. The training data consists of about 70,000 words and about 10,000 lines. The character error rates for the training data are 0.31% and for the validation set 0.62%. In this model, pages are included of the following 5 books. You can see I tried to select some books from the beginning of the century, from the end of the century, and from the middle of the century. There in December last year, I had 3 special models finished and available, and then I merged them to the general model. The general model consists about 170,000 words in the training data set and about 30,000 lines. The character error rate for the training data are 0.66% and for the validation set 0.95%. Although the model is tailored towards transcribing Neo-Latin texts set in Antiqua-based typefaces, I made the experience that very good results are also possible with texts in other Roman languages like English, Italian, or French. Our model is also able to handle some passages or some words in Greek and some passages or some words set in German Fraktur. I tried to follow those transcription guidelines and to give the user a maximum of freedom. Standardization in the transcription process have been kept to a minimum. Normalizations have been implemented only in the following cases. Ligatures and abbreviations have been expanded. The long S was transcribed as a normal S. Small caps weren't marked as small caps, but were transcribed as majuscules. And special characters like the sign for at, the e caudata, and those were also kept for the purpose that the end user has the maximum of freedom. There are at the moment a couple of known issues. There are occasional inconsistencies in the transcription of quotation marks, punctuation marks, and diacritics. The error rate for transcriptions of Greek words or passages is still high. The main problem there lies in the vast amount of different Greek typefaces that were used in the early modern times. To a lesser degree, also in passages and words which are set in German Fraktur, the error rate is not the best at the moment, but I'm working on it and I'm hoping that I can publish an updated version of our model in a couple of months. Yeah, thanks.
Any questions? So maybe just as an explanation, these are books, printed documents.
Yeah.
Did you try to expand the special characters?
Sorry?
Did you try to expand the special characters?
I had the earlier version where I expanded the special characters, but for the final version I decided to keep them because although many editors wish to standardize the edition they are going to make, but often they want to keep especially these special characters like the e caudata and so forth.
Any other questions? Okay, thank you. Now Günther Hackel will show us some public models. Günther is the second Günther in the Transcribus team, and therefore called often George. And many of you probably already had contact with him. He's one of the programmers and also does a lot of project management. And he was working with documents mainly from the NewsEye project.
Hello, I want to present the NewsEye project and more important, the public models which are and will be created during this project. So the motivation is that historical newspapers are really a great knowledge base for the scholars, general public, as well as the humanities researchers, but the access to them is limited, and also tools are missing with which you can investigate on them. So therefore this project came up, and it runs until next year in April. There are partners involved, and one speciality is that we have 3 types of partners. On one hand, libraries, computer scientists and also humanities researchers, so that they really can try immediately the tools which came up in the project and give feedback immediately. So it's not always easy, but I think it's worth to have them also in this project. Here are some examples of the newspaper pages. And our group deals mainly with data generation. So we use transcribers for this task. So we have to, on the one hand, create ground truth for all these research activities like layout analysis, text recognition, article separation, named entities. And we have also to process 1.5 million pages till the end of the second year. So, and as a first public model, the team in Rostock has trained one neural net for layout recognition of newspapers. It's already available via the layout recognition tool in transcribers. And of course, we also trained some model for text recognition. Here you can see examples for the trained model. So now this was also a training for you. I think tomorrow you all can read a German newspaper at the breakfast. Let's see. Please let me know. We took not the easiest training data, so it's from all over the time periods and all kind of images, good and bad images. And these are the statistics of these ground truth samples. We have around 442,000 words in the training set. And there is some interesting statistics. If you take the statistic of the German language, which says that a word has 6.5 characters in a word in average, then you have almost 3 million characters. And if you then know that the character E, for example, is distributed in this language statistic 17% of all characters, then you have almost 500,000 representations of the letter E in this training set, which is quite a lot. But of course, seldomly letter like Q is only represented around 600 times in this set. It's just a funny statistic. So we are quite satisfied with the results. As we heard already in the morning session, the guys from the linguistic department used this public model for their Alpine journal. And also someone took this data and trained a Tesseract model, for example, in Germany, and also others use it right now. And hopefully we get 2 other. It are free exactly because the National Library of Finland has Swedish and Finnish in the project, both languages, so we should get 3 other public models during the course of the project. And the PNF should follow very soon, so for the French. And here I want to show that you can also create article ground truth with transcribers. So it was really a challenge to make such a huge page. At least you have some colorful poster for your office, if you. But hopefully we have also some article model which we can make publicly available if it works as expected. So this is an ongoing research and will last some time till there are really good results. But of course the ground truth is there. And here are some other enhancements which we created in this project, where transcribers benefits from the project because we made an IOB export and as well as an import, so for the named entities, where you can also use already existent ground truth, and also the annotation feature is really getting enhanced. Yes, that's more or less the created public models in this project, in the news eye. Any questions? IOB, it's a format for the named entities. It's inside, outside, beginning. It's the short name of this.
Just out of curiosity, I have not understood the purpose of this multicolored page you showed us.
It's just, it's just an illustration of the articles inside this newspaper page. So each different color is an own article, and it's just to present it in a human, viewable way. So for the computer, it's just IDs in the page XML, but to let the user also see what articles are separated, we have these different colors for each article. Yeah.
So how does this work relate to the HAGA model that's in the interface?
No, this is something different. So the team in Rostock, the University of Rostock, will take this ground truth, article ground truth, and make an own training out of this ground truth. It's it's also machine learning, but a different attempt. Yeah.
I've got the microphone, so I've got a position of power here. So I wondered whether you were using OCR specifically for this and not HTR, and if so, which kind of OCR was being used. And also I'd like to know a bit more about the layout analysis and how that works, and if it's automated for picking out the columns of articles that you're transcribing, and are you separating those somehow from one another, or are you exporting everything off the page altogether, if you follow me?
So we used OCR, the Every Fine Reader, at the beginning to get the first version of the text and then corrected this text for the machine learning. So it was the first step. And for the layout recognition, it was trained on lines, on baselines only. So in this project, the use cases, you first recognize all lines. Afterwards, you recognize the text. Afterwards, you recognize the articles, and only after you recognize the articles, you draw the text regions around articles. The focus is not to recognize text regions at the very beginning during the layout recognition, but only after article separation. So the trained layout model for newspapers concentrates on lines and not on text regions.
Okay, thank you. Finally, we will hear something from the National Archives of the Netherlands.
Hello everyone, I'm going to make the presentation for our newest public model. For the last 2 years, our team in the digitization department has conducted many experiments with purpose to create a model which will be able to transcribe Dutch handwriting documents from the 17th, 18th and 19th century. After many attempts, research and experiments, our team finally managed to create a new public model that is available via Transcribus platform, and we call it Iceberg. Model Iceberg summarizes more than 1.5 million words and more than 800 different handwriting styles, around 5 scans per handwriting type. In order to reach a point that we will be able to produce a reliable model like this, we created many datasets with various material. This way, Iceberg is a dynamic combination of 2 models that respectively has been trained with VOC documents from the 17th and 18th century and notarial deed documents from the 19th century. Here you can see some image samples from the material that we have used. VOC documents from the 17th century, here as well. VOC documents from the 18th century, and 19th century notarial deed materials from the North Hollands Archive and 8 other state archives in the provinces. Our approach was quite simple. At first, we categorized the available scans into 3 different datasets. The first dataset contained VOC material from the 17th and 18th century. The second dataset has been trained with 19th century notarial deeds material from the North Hollands Archive, and the third with notarial deeds from 8 different state archives. For the training process, we used almost 6,000 scans in total, which correspond to more than 7,400 physical pages. Every model has been trained with HDR+ and 1,000 epochs. For the test set, we used additionally 60 scans, 1 scan per every 100 pages. The results that we managed to extract on the validation set were quite promising, with an average CR at 5.15. Finally, we combined these sets into one and we created the public model Iceberg. Although, despite the ambitious results, model testing was essential in order to confirm the model's efficiency. As you can see in this table, we created 6 different datasets that every one of them contains special characteristics such as different handwriting styles, different origin, and have been created at different time periods. The training results were actually remarkable, with the lowest CER level at 6.45 and the highest at 8. So, these results lead us to the conclusion that public model Iceberg can be very useful for users who want to process archives from the 17th until 19th century, and also can be used as a reliable base for training HDR materials. Thank you very much.
Thank you a lot. I especially like the name. Maybe you maybe there are some questions. I especially like the name Iceberg. Yeah. I also am looking forward sometimes for a model called Swiss Knife. Or something else which is then really capable to read everything. Are there any questions?
I think you also published a model in August last year.
The M3?
Yes.
Yep.
Can you tell the differences between those two?
Maybe Ms. Kaiser can help me?
I think it contained only 1/3 of the ground truth from this model is 3 times as big.
Well, I can confirm it works because I tried
Yeah.
it, so it's much better. Yeah.
Yeah. Thank you very much.
Thank you. So, one remark from my side, large models are often not better from the character error rate, but they are more robust. So you can feed more different styles to a model and they will still provide good results. And more special models often have better CER rates, but are not so robust.